Hi, everybody. It's Professor Mitchell. We are getting very close to the end of Chapter 6. Today, we're looking at Section 6.6, Solving Quadratic Equations by Factoring. So the objectives in this section are to solve quadratic equations by factoring, solve quadratic equations with degree greater than 2 by factoring, and find the x-intercepts of the graph of a quadratic equation in two variables. So those concepts are all very much related. We are working on the same SLO. This time we're going to be concentrating on the solve equations part. So I like to start this section by talking about the difference between expressions and equations. Up until this point, we've been looking at expressions. So expressions have directions like add, subtract, multiply, divide, simplify, or factor. Expressions do not contain equal signs in the original problem. And the answer is typically another expression as opposed to just a number or numbers. So all the problems we've done up to this point have been expression problems. The directions have always been factor, okay? So now we're going to shift gears a little bit and we're going to start looking at equations. So equations almost always have the direction solve. And they do contain equal signs. And the answer is typically a number or numbers. And the reason this is so important to point out right now is because students do often mix up factoring problems with solving equations problems. They look kind of similar. And really, I think it's just a matter of reading directions and looking for clues like, does the problem contain an equal sign or not? All right, so when we talk about a quadratic equation, we're talking about an equation that can be written in the form ax squared plus bx plus c equals 0, where a does not equal 0. So another name for a quadratic equation is a degree 2 polynomial equation. The largest exponent in this expression is 2, so that makes it degree 2. Quadratic is just another word for degree 2. So here's how we're going to solve these equations. And this is one of those things that I really enjoy talking about in a face-to-face class because every single time I've done this, I've been able to get students to say what I'm about to say before I have to say it, okay? All right, so here's the question. I'm thinking of two mystery numbers. And the only thing I will tell you about those mystery numbers is that when I multiply them together, I get 0. So what can you tell me about my mystery numbers? And I guess I've got the answer up here on the screen already. One of the special things about 0 is when you multiply two numbers together and get 0, that automatically means that at least one of those numbers has to be 0. That is a very special fact about 0. You can't add any other number. If I'm thinking of two mystery numbers that multiply to 7, you might be tempted to say the numbers are 7 and 1, but they could be 1/2 and 14, couldn't they? All right. But if the product of those two numbers is 0, I automatically know at least one of those numbers is 0. And we're going to use that fact to solve our quadratic equations. All right, so here's how that's going to go. The first thing we're going to do is write the equation in standard form. A lot of times they already come in standard form, but sometimes they don't. Then we're going to factor the left-hand side. Remember, factor means write the expression as multiplication, as a product. And then we're going to apply that zero factor theorem because after we finish step 2, we will have something, and this will make a lot more sense when we look at examples, but we're going to have something that says, okay, this thing times this thing equals 0. So what? Well, then one of those mystery things must be 0. Okay. All right. And that will give you two simpler equations, which are, I hate to say the word always, but I think I can say those two simpler equations are always going to be linear, all right? Linear equations are one of the things that you reviewed in the review quiz that comes at the beginning of this course. So hopefully you're pretty solid on your linear equations. And I just realized, because I'm about to switch over to my tablet, but let me show you what the examples look like. All right, so on a scale from 1 to 10, where 1 is the easiest and 10 is the hardest, I would say these start at a 1 and go up to maybe about an 8. This was a meme that I found several years ago. Unfortunately, it does have a little typo in it. I think there's supposed to be a 2 there. But anyway, I built example E around this meme. Okay, so let me bring up my tablet so we can start looking at these examples. All right, switching over to the tablet. We have example A, which, like I said, on a scale from 1 to 10, really is a 1. All right, this is the best form that your quadratic equation can possibly come in. In fact, I would say skip step 1. Do not write this one in standard form, because actually step 2 is already done. All right, it is in the form something times something equals 0. That's even better than standard form. Okay. All right, so according to the zero factor theorem, whenever something times something equals 0, that means that one of the mystery somethings is 0. So either x plus 4 is 0 or x minus 10 is 0. All right, and of course, if x minus 4 is 0, that means that x is negative 4. And if x minus 10 is 0, that means that x is 10. All right, so this equation has 2 solutions. Quadratic equations usually have 2 solutions, and those solutions are negative 4 and 10. All right, now I don't think I've had the opportunity to say this to you before. Remember how I told you that factoring problems you can always check by multiplying the answer back together? Solve equations problems can also be checked by putting the numbers that you think the solutions are into the original equation, okay? So just like I said for factoring, I hope I said this, I think I said this, please, please, please try to get into the habit of checking all of your solve the equation problems. I tend to be more generous on partial credit if I see a check, even if you get the wrong answer, than if I don't see a check. So I'm going to wait until we get to one of the slightly more difficult ones before I do a check. I think maybe on letter C, I'll do the check. All right, on a scale from 1 to 10, this one is probably a 2. All right, it's very similar to the last one. And as always, anytime you want to try a problem ahead of me, I totally encourage that. Just pause the video, try it, and then come back and compare notes. So once again, this is in the form something times something equals 0, which is the best form I can hope for, because whenever something times something equals 0, that means that one of those mystery somethings is 0. So it's either 3x minus 2 or 5x plus 1 that's equal to 0. If 3x minus 2 is 0, see, this is why I have you review linear equations, then 3x is 2. And if 3x is 2, that means x has to be 2/3. So at least one of the solutions to this equation is a fraction. And in fact, I think they both are. If 5x plus 1 is 0, that means that 5x is negative 1. And if 5x is negative 1, that means that x is negative 1/5. All right, so this equation also has 2 solutions. The 2 solutions are 2/3, and -1/5. When you do your online homework, you'll notice that you just have to type in the numbers. I think the curly braces, they give them to you. They're already there. So don't type them in again. Otherwise, your online homework program will unfortunately probably mark it wrong because it won't understand your answer. All right, next we have letter C. So once I get my solutions for letter C, I will check them because I want you to see what that looks like. All right, so on a scale from 1 to 10, I'd say this one is a 3. All right, it is in standard form. However, it is not factored. So we do have to factor this one. Now, I know I mentioned to you a section or two back that by the time you finish section 6.5 and do all the homework, that hopefully you are a factoring expert, because we're going to be factoring our little hearts out from now until the end of chapter 7 at least. I am not going to spend a whole lot of time in these problems explaining the factoring. All right, I'm going to assume that you are a factoring expert. Of course, I'm always happy to answer questions about factoring. Hey, Mitchell, why did this, work out like this? Or can you go over how to do this again? But I'm not going to spend time in these videos basically reteaching you factoring, because we just covered that in sections 6.1 through 6.5. All right. This type of factoring, we went over it in section 6.2. This is a trinomial with leading coefficient. Notice there's no GCF worth talking about. So we just jump right to the part where we look for the mystery numbers that add up to 2 and multiply to -63. And those mystery numbers are +9 and -7, right? Okay, and now it looks an awful lot like example A. So if something times something equals 0, that must mean that either x plus 9 is 0 or x minus 7 is 0. If x plus 9 is 0, that means x is -9. And if x minus 7 is 0, that means x is 7. All right, so let's check this one. I want you to see what the check looks like. I am going to check both of these. And I will start with x equals -9, I guess. Always go back to the original equation, before we had a chance to screw anything up. All right, so blank squared plus 2 blank minus 63 equals 0. I want to know, when I fill in that blank with a -9, does the equation work out? All right, so the square of -9 is 81. It's not -81, right? And 2 times -9 is -18 minus 63, and I think that does come out to 0. Woohoo! All right, and now I'll check the x equals 7. Squeeze it in over here. Put a little line there. All right, so blank squared plus 2 blank minus 63 equals 0. I want to know, does that work out when I put a 7 in the blank? Well, I think so. 7 squared is 49. 2 times 7 is 14. 49 plus 14 minus 63 does come out to 0. Woohoo! All right, so the two solutions of this equation are -9 and 7. All right, so far so good. 3 down, 3 to go. All right, this one says factor x squared minus 4x minus 45. So I put this in here to kind of emphasize something that we talked about earlier. This is the same kind of factoring that we just talked about. I'm looking for mystery numbers that add up to -4 and multiply to -45. Those two numbers are -9 and +5. All right, so is this the point where I should say, okay, and if that equals 0, that must mean that either x minus 9 is 0 or x plus 5 is 0, da, 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 da. Well, no, I shouldn't do that because this is not an equation. This is an expression. This problem could have come right out of section 6.2. All right, so the moral of the story is don't take the problem too far. Do exactly what it asked you to do, no more, no less. It asked me to factor x squared minus 4x minus 45, and that is what we have done. That's it. All right. Okay, so when you take the quiz or take the exam that has the factoring problems and the solve the equations problems, make sure you do the factoring problems as factoring problems, and you do the equation problems as equation problems. All right, now we have the problem that came from the meme. On a scale from 1 to 10, I'd say this one is maybe about a 6, okay? This one is not in standard form. It is an equation, by the way, so I'm not trying to trick you anymore. I mean, I never try to trick you, okay? But sometimes people let themselves be tricked. All right, this is an equation, but it is not in standard form. So the first thing we have to do is put it in standard form. And to do that, we put 0 on one side. So we're going to do -12 on both sides. And that's going to give us 2x squared plus 5x minus 12 equals 0. All right, why don't we look for a GCF? Because that's always helpful when there is one. In this case, I don't think there's anything helpful, but I'm glad I looked. Okay, so this problem could have come out of section 6.3 or 6.4, all right? And again, I am not going to spend a lot of time on the details of the factoring, okay? So let's see. Well, in order to get 2x squared, it would have had to come from 2x and x. I guess I'm kind of using the trial and error method. And then I need two numbers that multiply to 12, and I'll worry about the signs at the end. I think 3 and 4, as long as I put a plus here and a minus here. Okay. So I will leave it to you to check that that is correct, all right? And also make sure that you still remember how to do that. I mean, you just did it probably last week, right? In section 6.3 or 6.4. All right, and now this looks a lot like letter A or letter B. If something times something equals 0, the only way that could happen is if one of those somethings is 0. If 2x minus 3 is 0, that means that 2x is 3, which means that x is 3/2. And just in case I've never had the opportunity to say this to you yet, 3/2 is a perfectly good answer in an algebra class, all right? I've noticed a lot of people are uncomfortable with those improper fractions. They think they need to write it as 1.5 or sometimes 1.5. 3/2 is actually a perfectly good answer. Improper fractions like 3/2 are actually easier to work with in algebra than mixed numbers like 1.5. Okay? The only time you will probably see me ever write a mixed number is as the answer to a word problem. Okay. All right, x plus 4 is 0. That means x is -4. And so my two solutions are 3/2 and -4. Don't forget, you can check that. Okay. All right, so that brings us to our last example. This is an example of solving an equation, a polynomial equation with degree greater than 2. Okay. So the first thing I'm going to do is put it in standard form. Standard form really means 0 on one side. That's the most important thing about it. Okay, so that's going to give me 15x cubed plus 24x squared minus 63x equals 0. All right, and now I need to factor that thing. That thing does have a GCF. The GCF is 3x, isn't it? And when I factor out 3x, I am left with 5x squared plus 8x minus 21. Okay. So now let's see if we can factor 5x squared plus 8x minus 21. This is another 6.3 or 6.4 type factoring. It would have to be 5x and x. And I think the 23 comes from 7 and 3. And in order to get the plus 8x, this would have to be a plus and that would have to be a minus. Okay. So again, I'm not spending a whole lot of time on the details of the factoring. I am relying on you to be a factoring expert. If you need help with factoring, please, please, please ask me for help. Because if you're too shaky on your factoring, I'm sorry to say you're going to suffer a little bit through the next few weeks, really, all the way to the end of chapter 7. Okay, so now we have a slightly new situation. We have something times something times something equals 0. 3 somethings. Well, if you think about that for a few seconds, I think you'll agree that that would mean that one of those 3 somethings, at least, has to be 0. So either it's the 3x, or it's the 5x minus 7, or it's the x plus 3. So this equation is going to have 3 solutions, I think. If 3x equals 0, that must mean that x is 0. So my favorite number 0 is one of the solutions to this equation. That one's really easy to check, right? If you look at the original equation, it would just make it say 0 plus 0 equals 0. If 5x minus 7 is 0, that must mean that x is 7/5. I hope you can see that. And if x plus 3 is 0, that must mean that x is -3. So like I said, this equation has 3 solutions, the 3 solutions, and I would encourage you to check all 3. We already checked one of them. 3 solutions are 0, 7/5, and -3. All right, so going back to the presentation. All right, I'll just point out to you that I had my little troll face in here. That was supposed to come up after letter D. All right, I put that in there when I could be accused of being tricky by throwing a factoring problem in with the solve the equation problems. But keep in mind that on the next quiz and on the first midterm, you're going to have factoring problems and solve the equation problems all together. So it's important to know which ones are which. And that's going to do it for section 6.6. One section to go in chapter 6. So we'll see you for that next time.